Hello, this is Mrs. Baxter, and today we are going to take factoring one more step, and we're going to actually be solving quadratic equations by factoring. So what I mean by solving is we are going to find answers for x that make the equation true, okay? So in this unit, we're going to solve quadratic equations by factoring. So here we go. We're going to solve, which is important, by factoring, okay? And it's another way to find roots or solutions, which just means x without having to graph it. So I know you've learned how to graph in vertex form, and we found what our x-intercept was, and that's what roots and solutions are. So when you see roots or solutions, it means our x-intercept. Okay, where does the parabola cross the x-axis? Okay, so we're mathematically finding these 2 points. Okay, so the key concept here is that for any real numbers, meaning we've got the numbers that you're familiar with, a and b, if a times b equals 0, then either a is equal to 0 or b is equal to 0, or both a and b can be equal to 0, okay? So let's see, both a and b can equal to 0. So there's a couple different ways to solve this, but essentially what you need to know is that we are solving for x. So looking at this problem right here, x plus 5 times x minus 7, you know how to get to this point right here, okay? Now we're setting that whole equation equal to 0, and what we're doing is this next part here where it says then x plus 5 equals 0 and or x minus 7 equals 0, really what that looks like mathematically is this. We're just splitting this off, and we're now setting them both equal to 0. And x, actually I don't need this parentheses, but x minus 7 equals to 0. And then we're solving for x using multi or one-step equations, okay? So here's what it looks like when you're given an actual equation where we have to factor, okay? So factoring, the first step, this is really important, is making sure that one set equation equal to 0, okay? And in this instance, it is set to 0, x squared plus 5x minus 24 equals 0. Then we're going to follow our rules for factoring. We're going to go, okay, is there a GCF? Question mark. I don't see a GCF on this one. There's no greatest common factor. And so now I'm going to be looking for, is it a difference of perfect squares? Well, if you'll remember, a difference of squares means that you've got 2 terms and it's a subtraction. So difference is subtract. And we don't have that. So if you need to write yourself 2 terms only and it's a subtraction problem, but we don't have that here. Okay, so the next thing we're going to look for is it a trinomial? Is it a trinomial? And if it is a equals to 1? Well, in this instance, a is equal to 1. So we are going to be using number 4 for our example. And if you'll recall, we have to do what 2 numbers multiply together to get a times c, and what 2 numbers add together to get b. So let's go ahead and do that. What 2 numbers multiply together to get negative 24, but then add together to get 5? Let me think about it. Okay, well, use your factor sheet to figure out factors of 24, negative 24. And I know I could do 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay, all of those are factors. But when I look at 3 and 8, I'm thinking that is our best fit here. And the problem is I've got to somehow make it a negative 24, but a positive 8. So I'm thinking we're going to have a negative 3 here. That's going to work for both of those solutions. So when I put this together, x minus 3, x plus 8, don't forget it has to equal 0. All right, now we're going to do choo, choo. and you're going to set both of these, x minus 3 equals 0 and x plus 8 equals 0. Now, the nice thing about this is that we know that if I do 0 times this, I'm going to get 0. Or if I'm going to get this times 0, I'm going to get 0. So if either of these are 0, then those numbers are true, okay? So what we do is we're just going to add 3 to both sides. This goes away because that equals 0. So x is now equal to 3. And then here I'm going to subtract 8 from both sides because I want x by itself, and x is negative 8. Okay, those are my two answers for solving this equation by factoring. All right, let's look at another example here. Here I have another thing where number 1, I'm going to look, does this equal 0? Yes, it does. So since it's equal to 0, now I can look for my factors. It is not a difference of perfect squares. There is no GCF. And so I'm going to now look for two numbers that multiply together to get negative 21, but add together to get negative 4. All right, well, when I think about my factors, I know 7 and 3 fit the bill for negative 21, and it has to be a negative 7 so that we get negative 4 when we add them together, okay? So again, I love this one because it's x minus 7, x plus 3 equals, don't forget, it's this important part. And now we do choo, choo. And I say x minus 7 equals 0, x plus 3 equals 0. Now I'm going to solve for my x's. X is equal to 7, and x is equal to negative 3. Okay, those are my two answers. One thing to keep in mind is whenever you have an equation and whatever your highest exponent is, that tells you how many answers you're going to get for x's, okay? And in this case, since it's x squared, 2, we have 2 answers. Okay, let's try example number 3. Well, according to our rules of solving by factoring, we need to make sure it equals what? Yeah, it needs to equal 0. So is this problem set to 0? Well, no, it's equal to 12x, and we don't want that. So we can move terms around as much as we want. We just have to follow the rules of math. So I'm going to move this negative 12, I'm going to move this negative 12x to the other side. How can I do that? Well, let's just subtract 12x, because it's a whole term, subtract 12x. Now remember, we have to remember like terms, okay? Negative 12x is not the same as 36. It's not the same as x squared. I can't combine them. So I'm left with this equation equals, since these cancel out, it equals 0 now. All right, let's go back to our what two numbers multiply together to get 36? What two numbers add together to get negative 12? This one's a little trickier for me right now. Let's see, 36 is 3 and 13. Let's see, 2 and 16, is that right? No, let's see, 36. 36 divided by 4 is 9 and 4. I think that's going to work for me. 9, 4. Nope, that doesn't work either. Let's see. We have 2 and 36 divided by 2 is 18. That doesn't quite work. 36 divided by 3. Let me just make sure. Oh. Nope, that doesn't work either. 36 divided by 3 this is actually 12. Wow, that was big. Let's see here. So 36 divided by 3 is 12. What do we say? It was 9 and 4. 12, that makes it 13. 18, 17, 16. 12, 13. Nope, that doesn't work. 36 divided by... Oh! Haha! Look at that. 6 and 6. Okay, so sometimes you've got to try different ones because 6 and 6 is somehow 12. Right? Now I've got to get to negative 12. The only way I could get it to negative 12 is if both of those are negative, which makes that true as well. Okay, so I have x minus 6, x minus 6. And in this case, since both of them are the same, x minus 6 equals 0, right? Oops, that's not the answer. But if I do plus 6, x is equal to 6. Ta-da! And since these two are the same, this is essentially x minus 6 squared equals 0, you're just going to get, excuse me, the one answer, x equals 6. Okay? Last but not least, here's what I want you to do. Excuse me. I would like you to pause the video and try this on your own. So pause right here and then come back and see if we got the same answer. Okay. Well, here's the answer for this one. So hopefully you got the same answer. Just take a minute. If you need to pause the video, look at what the answer is that I got, and hopefully it matches yours. If not, come see me and I'll help you out with this one. Otherwise, you are ready to begin the homework.